3 years of law school taught me that a comma can cost a company $4 million. 10 years of writing software taught me that a missing semicolon can take down a production server at 2 in the morning. And a lifetime of being a nosy, word obsessed linguist taught me that the sentence, "we should get lunch sometime," can mean absolutely anything from "I adore you" to "please stop talking to me." Three different worlds, three different rule books for what a sentence is allowed to do. And underneath all of them, the same discovery over and over again. Language is not just a decoration. Language is not the wrapping paper around the idea. Language is the mechanism. It's code. The oldest code humans ever wrote, running on the oldest, buggiest, most gloriously unpredictable hardware there is, other people's brains. Today, we're going to open up that idea and really look inside it. We'll walk through 4 layers of language: the language we use on each other, the language of law, the language of computers, and the strange new language of talking to a machine that has read every book, but understood none of them the way you would hope. By the end, I want you to think about your inbox, your contracts, your code, and your AI prompts as 4 dialects of the same exact skill. Because once you see that, you can't unsee it. And you start getting a lot better at all 4 at once. This is Automate Office Work. Let's get into it. If you're new here, my name is Justin. I'm your host, a techie lawyer. I studied computers and linguistics before studying law, and we're going to go over a mix of them today. But I've got an entire podcast that you might be interested in exploring. It's available on all the major platforms. And if you could do me a favor and comment, like, subscribe, and share, it would help us to reach more people. If you'd like to find all the rest of the podcast episodes, you can search wherever you're getting this content. You can search for Automate Office Work, or you can go to our website, automateofficework.com/podcast, and you'll see the list of all the 88 previous episodes. I think it's 80, or it's about 88 now. And you'll find all the links to all the different platforms for each of the episodes. And if you'd like to connect with me and suggest future episodes, or to see if you'd like to come on as a guest to go over your journey, feel free to reach out to me on my website. Let's start with the messiest, oldest, and honestly most impressive programming language ever devised: the sentence. Here's the strange thing about talking to another person: you have a model of the world in your head. They have a completely different model of the world in theirs. Different memories, different assumptions, different emotional weather on any given day. And your job, every time you open your mouth, is to take something that exists only inside your skull and get it running correctly inside someone else's, using nothing but sound waves or squiggles on a screen. That is structurally exactly what a programmer does when they write code for a machine. You have an intention, you encode it into a shared symbol system. The other system, human or computer, decodes it, and if you did it right, it now behaves the way you wanted it to. The difference is the hardware. A computer has no assumptions of its own. It has no bad mood, no history with you, no competing agenda. Another human has all three. So natural language evolved to be extremely lossy but extremely resilient. It's built to survive being misheard, half understood, and reinterpreted through someone else's mood, and still mostly get the job done. Think about how much is writing on context that's never actually spoken. If I tell a colleague, "Can you take a look at this before Friday?" I'm not just asking a yes or no question about their eyesight. I am invoking an entire shared understanding of urgency, hierarchy, politeness norms, and what "take a look" means in our specific working relationship. Depending on our history, that sentence could mean "please drop everything," or it could mean "whenever you get a chance, no pressure." Same code, different runtime environment, different output. Linguists have a name for this: pragmatics, the study of meaning that lives outside the literal words, in shared context, tone, and inference. It's the layer where the "nice weather we're having," said sarcastically during a thunderstorm, correctly executes as a complaint rather than a meteorological observation. No dictionary on earth defines it that way. You just have to already share the model. And here's the part that should matter to anyone running a team or writing emails for a living. Most workplace communication isn't a vocabulary problem. It's a compile error between two different mental models. Someone asks for a quick summary and means three bullet points. The other person hears a quick summary and produces 4 pages because in their last job, that's what quick meant relative to the alternative. Nobody used the wrong words. They just had different runtime environments. This is also why the best communication, the best negotiators, the best managers, the best partners aren't the people with the largest vocabulary. They're the people who are best at modeling what's already loaded into the other person's head and writing to that interpreter, not to some imaginary neutral one. That's a skill. It's arguably the original skill of civilization. Every trade agreement, every marriage, every successful team stand up meeting is a successful compile. And when it fails, when the message doesn't run the way you intended, we don't call it a bug. We call it a misunderstanding. And we shrug because we've collectively agreed that this is just the cost of doing business in the human language runtime. It's remarkably fault tolerant. It has to be. It's been patched by every culture, every generation for tens of thousands of years, and it still basically works. But basically works is a very different bar than the one we're about to look at next, because there's one very particular use of human language where basically isn't good enough, where ambiguity isn't a bug to be tolerated, it's a feature to be engineered on purpose. I'm talking about the law. Law is the strangest dialect of language that humans have ever built because it was designed on purpose to be two contradictory things at once: precise enough to bind you and flexible enough to argue about. Think about a phrase like reasonable person. It shows up constantly in contracts, in negligence law, in employment disputes. It sounds almost comically vague. Reasonable according to whom? A reasonable person in 1890 and a reasonable person today would disagree about almost everything. And that's not a flaw in the phrase. That's the entire point of the phrase. It's a variable deliberately left undefined, so the law can be applied to situations nobody could have predicted when it was written. That's function based thinking. A statute passed decades ago still has to run correctly on cases the original drafters never imagined. New technology, new social arrangements, new forms of harm. If the language were airtight and specific, the law would break the first time reality did something unexpected. So legal language builds in deliberate abstraction, almost like a function parameter. So the same clause can be called with different arguments across 100 years. But then, right next to that soft, flexible language, you get the opposite instinct: brutal, almost paranoid precision. Contracts define terms in all capital letters. Confidential information means exactly this and nothing else, as enumerated in section 1.2, subsections A through F. Why? Because the moment you leave a term undefined, you've handed a gift to whichever side benefits from ambiguity. Good contract drafting is basically writing a program where you close every loophole you can think of because you know that somewhere out there, someone is going to stress test your syntax looking for an edge case. Here's a story that captures the whole tension. There's a famous case, the Peerless case from the 1860s, where two parties agreed to a shipment of cotton to arrive on a ship called the Peerless. Except there were two ships named Peerless, sailing months apart, and each party had a different one in mind. Same words, two totally different intended executions. The court had to decide when the symbol points to two different real world reference and neither side is lying, what happens to the contract? That's not a moral failure. That's a naming collision. The exact same bug you get in code when two libraries both declare a variable called X and nobody notices until runtime. And that's really the whole game of being a lawyer, isn't it? You're a language engineer. Half your job is drafting, choosing the tightest possible words so the contract executes the same way, no matter who's reading it or when. And the other half is litigation, where you take the same language someone else wrote and go looking for the ambiguity they didn't know they left in, the unhandled exception, the missing else clause, and you argue that the silence should run in your client's favor. A good contract lawyer thinks like a good programmer, defending against malicious input. What happens if the counterparty interprets this clause in the least favorable way possible? What if there's a typo? What if a defined term gets used before it's defined? Legal drafting is genuinely one of the closest things to programming that exists outside of an IDE. Except the compiler is a judge. The runtime errors show up years later, and there's no git blame to tell you who wrote the ambiguous clause in 2014. So law sits in this fascinating middle position on our spectrum. More disciplined than a text message to your coworker, less disciplined deliberately than a line of Python, because law has to survive contact with a changing world, and code usually doesn't. Which brings us to the far end of the spectrum, the language with almost no wiggle room at all. If human if human language is jazz and legal language is a carefully arranged orchestral score with room for a conductor's interpretation, computer code is a metronome. It does not care about your mood. It does not care about your context. It does not care what you meant. It cares with total indifference about what you typed. This is the language dialect where ambiguity isn't a feature. It's not even tolerated as an occasional cost. It's eliminated by design. A computer, at the level it actually operates, doesn't understand English or Python or anything else. It understands electrical states, on or off, ones and zeros. Every layer above that, the programming language, the compiler, the operating system, exists purely to translate human legible instructions down into that binary reality without losing a single bit of meaning along the way. That's why code has to be so unforgiving about syntax. In spoken language, if you drop an article, going to store, instead of going to the store, everyone still understands you perfectly. In code, drop one character, one bracket, one colon, one semicolon, depending on the language, and the entire program can refuse to run at all. Not run a little bit wrong, refuse. Full stop. There is no partial credit in a compiler. But here's what I think is genuinely beautiful about code, and what people who don't write it often miss. The rigidity is also its superpower. Because the rules are so exact, the same instructions produce the same result every single time on every machine that correctly implements the language. A Tuesday morning in Amsterdam or a Sunday night in Tokyo, 10 years apart. Natural language can't promise you that. Law can't promise you that. Only code gives you that guarantee. And that guarantee is precisely what allows us to build skyscrapers of software on top of other software, trusting each layer without rechecking it every time. This is also where the concepts underneath the syntax matter more than people expect. You don't actually need to memorize every command in a language to be good at automation. You need to understand a small number of underlying ideas that show up in almost every language in some form. A variable is just a labeled box that holds a value. A loop is just do this again until a condition changes. A conditional is just if this is true, go this way. Otherwise, go that way. A function is reusable, named chunk of behavior. Very much like that reasonable person clause we just talked about in law. Define it once, call it many times, with different inputs. Once you actually understand those handful of concepts, moving between programming languages is much more like moving between related dialects than learning something from zero. The vocabulary changes. The grammar of thought underneath it barely does. And that overlap with law is not a throwaway comparison. It's structurally real. A contract clause and a function are doing the same conceptual job. Take an input, apply a fixed rule, produce a predictable output, and make sure the rule still works no matter who or what triggers it later. The lawyer writing, "The tenant shall pay the landlord X dollars on the first day of each month," and the programmer writing a monthly billing function are both, in the deepest sense, doing the same act of language, specifying a rule so precisely that its execution doesn't depend on interpretation. The failure modes look different, though, and that's worth sitting with for a second. When a contract has an ambiguity, you get a lawsuit, sometimes years later, argued in front of humans who bring their own judgment to bear. When code has an ambiguity, or more accurately, when code has a bug, because true ambiguity mostly can't survive a compiler, you get an error message, usually right away, argued in front of nobody, resolved by rereading your own syntax more carefully. Code fails fast and mechanically. Law fails slowly and socially. Human conversation barely fails at all in a way anyone notices because we've built enormous social tolerance for its errors. We call it being a bit awkward and we move on. So we've now walked all the way down the spectrum. Language that tolerates enormous ambiguity because the receiver is flexible, forgiving human mind. Language that's engineered to hold precision and flexibility in the same sentence on purpose. And language that tolerates none whatsoever, because the receiver is a machine that does exactly and only what it's told, which raises an extremely interesting question for right now in 2026. What happens when the receiver on the other end is a machine that talks back to you in the loose, ambiguous human dialect? We talk a lot on this show about how technology should serve humans, not replace them. That's why I'm so excited to share that I've partnered with Ira. Ira, AIRA, is an AI powered customer communication tool that actually aligns with the values we discuss here at Automate Office Work. And here's the best part: Ira doesn't write your emails for you. It doesn't hunt down cold leads to spam people. Instead, it focuses on the most valuable asset you already have: your existing relationships. It removes the drudgery of tracking so you can focus on the joy of connecting. I saw the need for this in my own life. I don't need thousands of new contacts. I need to stay close to the thousands of amazing people I already know. I used to run a complex manual system tracking when I last spoke to a partner and setting alerts for when to reach out again. It was a commitment to make sure my relationships didn't just fade away into the noise. Ira takes that intention and gives it superpowers. It connects to your contacts and sends you reports when their companies show up in the news. It gives you the signal, the important life events and business updates, so when you do reach out, you're genuinely informed about what matters to them. It's available now in 14 countries across Europe for €149 a month. It's AI done right, handling the admin so you can be more human. If you want to support this show and strengthen your own network, head to get.ira.app/automate. Using that link helps support my work here, and I truly believe it will help you lead a more intentional, connected professional life. Now let's get back to the show. For the entire history of computing, up until roughly a few years ago, talking to a machine meant speaking its dialect. You learned its syntax. You respected its rigid grammar. You didn't get to be sloppy because the machine had no capacity to guess what you meant. Generative AI broke that rule for the first time in history, and it broke it in a genuinely strange direction. Suddenly, you can talk to a machine in loose, ambiguous human sentences, the exact dialect from our very first segment, and it will often produce something useful back. That feels like magic. It also creates a very specific, very predictable kind of disappointment. Here's the mental model I want to offer you, because I think it fixes about 80% of the frustration people have with AI tools. You are not talking to a database, and you are not talking to a colleague. You are talking to something much closer to a brilliant, extremely well read intern on their very first day at your company. Think about what that actually means. This intern has genuinely read an almost unbelievable number of books, contracts, code bases, articles, and conversations. Ask them about the general shape of contract law, or the standard architecture of a web app, or how most companies handle client onboarding, and they'll often give you something impressively competent. But they've never worked at your company. They don't know that your firm always uses a particular liability cap. They don't know how your code base has a legacy authentication system from 2019 that nothing is allowed to touch. They don't know that when your team says the usual template, they mean one very specific document sitting in a folder they've never seen. And critically, and this is the part that trips people up, this intern does not reliably know the difference between "I recall this precisely" and "this sounds like the kind of thing that's usually true." That's not a moral failing on the intern's part. It's a structural failure feature of how large language models work. They are extremely good at producing text that's statistically consistent with everything they've absorbed. And confidence in the tone of an answer is not the same thing as confidence in its accuracy. A hallucination doesn't feel like a lie from the inside. It feels to the model exactly the same as a correct answer because both are just the most plausible next words. We expect infallibility because the writing sounds so fluent, and fluency has nothing to do with truth. That mismatch between how confident the output sounds and how confident it actually is the single biggest source of disappointment people have with these tools. So, how do you actually work well with a brilliant intern who's read everything and knows nothing about your specific situation? You do exactly what you do on their real first day of work. You give them context. You don't hand a new hire a one line task and walk away, and then act shocked when they guess wrong. You explain the background. You show them an example of what good looks like in your world. You tell them which constraints are non negotiable and which are just preferences. You tell them who the output is for. And this is the part experienced people skip and then wonder why the work is unusable. You review what they hand back with the same care you'd apply to a first draft from any junior colleague, because it's exactly that, a first draft from someone new who did their best with the information you gave them. This is, again, a language problem before it's a technology problem. Prompting well is essentially legal drafting and pragmatics fused together. You need the precision instinct of a contract lawyer, defining your key terms so there's no room for the model to guess wrong. And you need the context instinct of anyone who's ever successfully communicated with another human, supplying the shared background that would otherwise have to be inferred. The people who get startlingly good results from AI tools are very rarely the people with some secret technical trick. They're the people applying the exact same communication skills we've been discussing this whole episode, just now aimed at a fascinating, fluent, and occasionally overconfident new kind of listener. So let's put all four dialects on the table at once, because I think the shape underneath them is the real takeaway here. Ordinary conversation sits at the loose forgiving end, massively ambiguous, but built to survive that ambiguity through shared context and social repair. Law sits in a fascinating middle position, deliberately precise, where precision protects you, and deliberately flexible, where flexibility lets the system evolve. Code sits at the strict end, zero tolerance for ambiguity, total consistency in return. And AI is the strange new hybrid. You get to speak to it in the loose human dialect, but underneath, it's still a system, and it rewards the same discipline that makes contracts and code work: clear terms, clear context, clear expectations. If there's one skill running through all four of these, it's this: know exactly how much precision the situation actually needs and supply exactly that much. No more, no less. Over specify a casual conversation with your partner, and you sound like a robot. Under specify a contract, and you end up in litigation. Under specify a line of code, and it simply won't run. And under specify a prompt to an AI, and you'll get a fluent, confident, occasionally beautiful answer to a question you didn't actually ask. That's really the unifying discipline behind automating office work well. It's not really about learning tools. Tools change every year. It's about getting sharper at this one underlying skill, encoding an intention into language precisely calibrated to whoever or whatever is going to decode it on the other end. Do that well with a colleague, and you get fewer misunderstandings. Do that well with a contract, and you get fewer disputes. Do that well with code, and you get fewer bugs. Do that well with an AI system, and you finally get to stop being disappointed by your very well read, slightly overconfident new intern and start actually delegating to them. If you've made it this far, you're probably enjoying the content that I have to offer. And if you would like to show some generosity and give back to me in support of my work, you can do so at buymeacoffee.com/automate office. Contributions are voluntary and you can make them in whatever amount you would like at whatever recurring frequency you would like. And now let's wrap up this episode. So, next time you're drafting an email, negotiating a clause, debugging a function, or arguing with a chatbot that's confidently made something up. Remember, you're not doing four unrelated things. You're doing the same thing four times in four dialects on a spectrum that runs from wonderfully forgiving to utterly unforgiving. Get good at moving along that spectrum on purpose instead of by accident. And just about everything you do at a desk gets a little bit easier. That's it for this episode of Automate Office Work. If this reframed how you think about the words you send, the contracts you sign, the code you ship, or the prompts you write, share it with someone who spends their day doing all four. And until next time, happy automating.